Hi guys, this is Miss Scott and we are going to take care of the section 7.4 notes in geometry. Before that, here's your bad joke. So how does Moses make his tea? Well, he brews it. Because Moses was a Hebrew. All right, good one. Okay, so let's get started. In this video, you are going to learn about two different types of special right triangles, and then there's some formulas that you can use to find if you're only given one side length in one of these special right triangles, you can actually find the other two. All right, so your essential question is how do you find missing side lengths? And then that is of a 45, 45, 90 triangle and a 30, 60, 90 triangle. All right, so the first type of triangles that we are going to look at are 45 degree, 45 degree, 90 degree triangles, or in other words, just 45, 45, 90s. And then we're going to do three examples using those types of triangles. So go ahead and draw a triangle and try to make it so that these two legs are the same length. And then if you know that these acute angles are 45 degrees, what actually happens here is that these two sides have to be the same length, so the legs are equal. And then if you take the length of that leg and multiply it by the square root of 2, you'll get the length of the hypotenuse. So written out in words, we would say the hypotenuse is equal to the leg times the square root of 2. All right, so let's go ahead and use this formula right here to do examples 1 through 3. All right, so first of all, notice that we have a 45 degree angle and a 90 degree angle. So of course this here is going to have to be 45 degrees as well. And we really don't need to do any work to find y, so let's do that first. Y has to equal 3 because remember those legs are the same length. And now we can set up hypotenuse equals leg times the square root of 2 to find x. So x is our hypotenuse. We just talked about this. The legs lengths are 3. So if we take 3 times the square root of 2, we could write our answer like that. If you prefer decimals, you could plug in 3 times the square root of 2 in a calculator, and that will give you about 4.24. All right, so that's the decimal form there. And for me, it's okay if you want to write it as radical form or decimal form. In my class, I'm not really too picky about which form you want to use. Okay, let's look at another example. All right, so example 2, again, we've got a 45 degree, 90 triangle. And again, just like in example 1, finding y is pretty easy because it's given. Y has to be the same as the square root of 6 because the legs are equal. All right, and then again, we can set up hypotenuse is equal to the leg times the square root of 2. And again, our hypotenuse, they're calling x. The leg is the square root of 6 times the square root of 2. And since these are both square roots, we can actually just multiply them together. And 6 times 2 would give us x equals the square root of 12. Now, if you plug that into a calculator, you'll get about 3.46. If you do want to write your answer in simplified radical form, we would split this into the perfect square of 4 times 3. And then the square root of 4 is actually 2. So 2 times the square root of 3, or 2 root 3, would be that answer if you were asked to write it in radical form. But again, for my class, if you want to put it in decimal form, you could do that here. Again, if you want to plug in the square root of 6 into a calculator, you could go ahead and do that. That ends up being about 2.45. All right, so this would be the simple or the approximate decimal form. All right, now let's look at one example, example 3 here, where actually they give us the hypotenuse and we are going to find the lengths of the legs. All right, so we'll jump right into the formula because we don't know either of the legs. We're going to start with hypotenuse equals leg times the square root of 2. The length of the hypotenuse here is 2 times the square root of 2. The legs are using x to represent. All right, so to get x by itself, notice that we need to divide by the square root of 2. So over here, we're also going to divide by the square root of 2. And these square root of 2's cancel, so do these here. So we actually end up with x being exactly 2 in this problem. All right, so that means both these legs here would be 2 units long. All right, so hopefully the 45, 45, 90 triangles aren't too tough to work with for you. Now let's get into our next theorem, which deals with 30 degree, 60 degree, 90 degree triangles. And now when you do these types of triangles, we have 2 different formulas because we have 2 different angle measures. So when you draw this triangle, make sure that one leg is shorter than the other. And then we have a right angle here, a 60 degree angle here, and a 30 degree angle here. That's a little hard to see, but this right here is a 3. So let's be a little more clear about that. Okay, and what turns out to work in this case is if we call the short leg x, and then we can actually take that shorter leg and multiply it by 2 to get the length of the hypotenuse. And again, we can take that short leg and multiply it by the square root of 3 to get the length of the longer leg. So if we write these formulas out in words, the first one is that the hypotenuse is equal to 2 times the short. And the other formula we're going to use is that the long leg, or I'll just say long, is equal to the square root of 3 times the short. All right, and when I'm talking about long and short here, long, I'm just referring to that longer leg. For the short in this right triangle, I'm just referring to the shorter leg. All right, so just a FYI when you're using those formulas. So here again, we have 2 formulas because we have 2 different angle measures here. So let's practice using these. In example 4, the first thing I like to do is just label what sides are what. So this 2 right here is the short. V is the longer leg, so that's what we're calling the long. And then U is our hypotenuse. Okay, so you can start, if they give you the length of the short leg, you can start with either formula. So I'm just going to start with hypotenuse is equal to 2 times the short. All right, well, in this case, the hypotenuse is U, and then times is equal to 2 times the short, which is 2, so U is 4. All right, so now we can start over using the second formula. Long is equal to the square root of 3 times the short. Okay, so in this case, the long leg is V. The short leg is 2. So if we take the square root of 3 times 2, you could write that just as 2 square root 3, or if you plug it into a calculator to get a decimal approximation, it turns out that that's about 3.46. All right, so there's just a little practice with how you can use those formulas if they give you the short leg's length. All right, well now let's look at what if they give us the hypotenuse instead. So that's what we're going to look at here in example 5. Okay, so again, I always like to start by labeling stuff. So since 16 is across from the right angle, this is our hypotenuse. And now we're calling y here is the short leg, and x here is the long leg. And in all of these examples, it's good to just start by noticing that this is a 60 degree, this is a 90 degree, so over here this would have to be a 30-degree angle. So just so you can verify that you can use those formulas for 30, 60, 90s. All right, so now notice here we are given the length of the hypotenuse. So we have to start with the formula that has hypotenuse in it. So hypotenuse, remember, is equal to the short leg times 2. So in this case, 16 is equal to, here they're calling the short leg y times 2. And then to get y by itself, we can divide by 2. So these will cancel here. And we end up with 8 is y. Or in other words, 8 is the length of the short leg. Okay, so now that we know what the short leg is, we can use our second formula. Long is equal to the short times the square root of 3. So here they're calling the long x. The short we just calculated, that's y, but now we know that that is 8. Okay, so we're going to take 8 times the square root of 3. And you could leave your answer just like that. That would be your simplest radical form, 8 root 3. Or if you plug it into a calculator, that's approximately 13.86. All right, so that would be the length of our long leg. Okay, so we got our short leg and our long leg, and let's do one last example. All right, so example 6, let's start by labeling what we know. So we know that 2 square root of 2 is the hypotenuse. And then we have our short leg is B, and our long leg is A. All right, so again, we have to start with what we know, which is the hypotenuse. So that formula is hypotenuse equals short times 2. And we can fill in, so hypotenuse is 2 square root of 2. And then the short is B times 2. Okay, so if we want to get B by itself, we need to divide by that 2 next to it. So if we divide both sides by 2, these cancel. And over here on the left, these 2's also cancel, so we end up with the square root of 2 is equal to B. And again, if you prefer decimal form, square root of 2 is about 1.41. All right, so now we know the length of the short is the square root of 2. All right, so then our last step here is going to set up that the long equals the short times the square root of 3. So now we know the long, we're using A for that. The short we just calculated is the square root of 2. And if we multiply that by the square root of 3, we end up with the square root of 6, which would be your simplest radical form. And as a decimal, the square root of 6 is approximately 2.45. All right, so there is the length of the longer leg. All right, well, thank you guys for watching. I hope that those formulas for calculating the lengths of 45, 45, 90s and 30, 60, 90s made sense. If you have any questions or comments, leave those down below or come find me at school, and we will see you guys next time. Adios.